there's a crate. It slides across the floor to a stop. If its initial velocity was 2 meters per second and it took 3 seconds to stop, what was its acceleration? And what is the coefficient of friction? Okay, problem just like this on the test. So listen up. Let's do given, find, and solve. Okay. Let's do this back a little bit. So given. So the first step is, of course, to draw a picture of the situation. Here's the floor. Here's our crate. And no mass is given. I'll put M right there. Now, if I don't give you the mass on a problem, if you feel comfortable, if it makes you feel comfortable, you can always make one up. But probably what's going to happen is it's going to cancel out. Or you can just express the answer in terms of the mass. But okay, and so we've got an initial velocity here of 2 meters per second, and it slides to a stop. So here's our final velocity is equal to 0 after 3 seconds. And so what are we trying to find? For part A, oh, I'm sorry, I'm off screen. Let me know. So we want to know what is the acceleration and what is the coefficient of kinetic friction, right? It's kinetic friction because we're sliding. So let's solve it. Well, to find the acceleration, we know the change in velocity and the time, so that's going to be pretty easy. V equals V naught plus AT. That's our first kinematic equation. So have those kinematic equations ready. You know, have your equation list ready to use. And so the acceleration is V minus V naught over T. You can also just think, what is acceleration? Delta V over delta T, and you can use that equation as well, because that's what acceleration is. So this is 0 minus 2 meters per second divided by 3 seconds. And so the acceleration is 0.667. We'll do 3 significant figures here. Meters per second squared in the negative direction, right? So that's not much of an acceleration. So it's pretty slippery stuff, I think, we're going to find. Okay, now let's do part B. I think we got enough room here on the paper. Now, whenever I'm coefficient of friction, well, I can start with what I'm trying to find. I know that the force of friction is equal to mu times the normal force. This should be on your equation list now, right? You have it on. Are you adding to your equation list? Okay, make sure you do that. And now we can solve for mu. Mu equals the force of friction divided by the normal force. And so this tells me what to do. I need to figure out what the force of friction is and what the normal force is. And when I'm trying to find forces, I use the procedure. So I'm going to isolate my object of interest, my crate. I'm going to draw a free body diagram of it. I've got the weight pulling it down, mg. I got the normal force of the ground, supporting its weight. And as it's sliding to a stop, the only other outside force acting is the force of friction. And we'll make this the positive x direction and this the positive y direction, as we usually do. So this is step 2, step 3, now step 4. Let's go ahead and sum the forces in the x direction. That'll be equal to ma in the x direction. So let's look in the x direction. There's only one force. So that force of friction is equal to ma. Now, do I know what m is? No. But I do know what a is. Okay, I figured that out in part A of the problem. Okay, now let's sum the forces in the y direction equals ma in the y direction. Kind of not necessary at this point. If you want to skip this part, you can, but you need to at least think about it, okay? Because what are the forces in the y direction? Well, I've got the normal force minus the weight equals, and there is no acceleration in the y direction in this problem. So 0. So what is that telling me? That the normal force is equal to the weight. Okay? Now I think, wait a minute, I know what G is, but I don't know what M is. Is that a problem? Not really, because let's go back to this now. I mean, what I'm trying to find mu, so let's plug in our expressions now for the force of friction and the normal force. Mu is equal to the force of friction, but we said the force of friction is equal to ma. And the normal force is equal to mg. So what do we see is happening to the mass as I'm trying to calculate my coefficient of friction? The mass cancels out. So I don't need to give you the mass. Now, if you think you need the mass, you can just keep it as a variable in the expressions and then see if it cancels out, or you can make one up. But what will happen is if you make one up, like if you said 10 kilograms, you would get 10 times, you would get 6, and then here you would have, 98 newtons, and then when you do the division, you'll get the same answer. So now, the acceleration is negative 0.667 meters per second squared, but when you're dealing with the coefficient of friction, this negative just gives you the direction of the acceleration. You don't need that. So it's really just 0.667 meters per second squared divided by g, which of course is 9.8 meters per second squared. And so mu, I have to tuck it way down here in the corner, mu is equal to 0.0 what? 0.068. Yeah, that's good enough. Does it round off to 8 there?
No. Well, yeah, round off to 0.680.
Okay, yeah, that's good. So we can just leave it like that. Now this is pretty slippery stuff. If you have a coefficient of friction that's 0.1 or less, you're dealing probably with like an ice rink or something. The floor of this room, the concrete floor of this room, when I slid that to it was a lot more than that. I think 3 seconds to stop, that's 1001, 1002, 1003. When you're only going 2 meters per second, that means it's pretty slippery. So typical coefficient of friction, like if you're driving or you're riding your bike or something on a dry pavement with the the rubber of the tire, it's probably about 0.8, 0.9. I mean, that's what you're looking for. So anyway, so that, let me zoom all the way out here. You can see the whole thing. That is how you do a problem, the whole problem. And again, something very similar to this will be on the test next week. So study hard.